Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and today we are talking about the James Webb Telescope. Hey, Ben, how are you?
Hey Simon, hey fellow Econauts. Yeah, today we talk about what is the James Webb Telescope and what can we do with it and so on. And we want to keep it light, so we don't want to go too deep into the science here, because if we go into that, then we go very, very deep into the galaxy.
Yeah, and it's probably a long episode otherwise. Let's
Yes,
let's jump right into it with the first question. What is the James Webb Telescope?
it's a telescope.
That's what I said.
Well, it's a bit more than that, obviously. I mean, it is a telescope, but it's a telescope which is at a Lagrange point between Sun and Earth. It's actually not between, but behind. But which means it's a stable position in an equilibrium between Sun and Earth, and it means it doesn't move relative to us, and it is outside of our atmosphere. Therefore, there's no light pollution from humans. There's no atmospheric interferences and so on. So we have a clearer view, and it has a way larger diameter because it's suspended in no gravity. So therefore, you can obviously build this whole thing a bit bigger as well.
We already had one telescope in orbit, which is the Hubble. Maybe you can let us know what the difference between the Hubble and the James Webb are.
I think it is easy to say there will be heaps of differences between both telescopes, just given the fact that the Hubble telescope is way older, and obviously we have developed better technology since the Hubble telescope has been launched. However, let's just focus on two very significant ones. So one is that the James Webb telescope has a way larger reflective surface, the mirror, than the Hubble telescope. The Hubble telescope has, like, if you put a person beside of it, I think an average person is, let's say, 1 meter 70, 1 meter 80. The Hubble telescope has a diameter of 2.6 meter. So that means, you could sort of put a human in that mirror. The James Webb telescope is made of multiple hexagonal mirrors, which are placed together. And these mirrors, like each of those hexagonal mirrors is like 3/4 of a human, and we have, I don't know, like I think 17 or so. So the overall area of the reflection is like 6 to 7 times larger than the Hubble telescope. So you can capture way more information. It's like having a fish net and you go through the water. If you have a very small fish net and you go through the water, then you might catch a little bit fish. If you have a really huge net have a really huge net, and then you would catch way more fish and things in the water, obviously. And that's the same principle here as well. You capture more light. The other huge difference is the operation of frequency. So the sensors for the James Webb telescope operate in the deep infrared band, whereas the Hubble telescope operates in the ultraviolet, like in the lower ultraviolet, visible light, and the upper infrared band. That means, so it happens to be that most of the stars emit infrared light. Therefore, if you have a larger sensitivity in infrared, you can also capture way more information, and that gives you clearer images. Whereas when you have lots of light, which is actually not really visible, then imagine looking with the naked eye. You can't see everything in the sky because our eye cannot see certain bands of light. So I guess we keep it at this to not go too much into detail.
With that being said, the technology advancement, of course, will also lead that we have probably discovered new things or things that we haven't really catch with the Hubble telescope. Anything that the James Webb has already discovered for us?
One major thing, and that made also most of the impact on YouTube and in the news, where people claimed, "Oh, the James Webb telescope that disproves our theory of the universe," and so on. It's not quite like that. What it really means is that the theory we have so far is not entirely correct. So the James Webb telescope enabled us now to advance. So we must have missed something with the old theory to advance that theory. What it actually discovered was star systems which are older than our current theory would have predicted. So therefore, our calculations of how old our universe is has been not entirely correct until now. Is the James Webb Telescope the final answer? We don't know that, but it shows us that there's more things to consider And other things it has discovered are, other black holes, other stars. It also made some pictures of the same areas the Hubble telescope did, and you can see huge differences. The clarity of the pictures, the amount of information. It's fantastic. One thing I also wanted to mention is one technology the James Webb Telescope uses is similar to what our eye does. Our eye actually is not a really good camera. It's not very clear. We see when you would take a picture with our eye and you would put it on screen, it's a very blurry mess. You can't actually see anything, even with our lens and everything. The reason why we can see as sharp as we do is our eye has little micro movements and sort of goes in both, like in all directions a little bit. And these movements enable our brain to put these pictures together and make a clear picture. And the James Webb Telescope is doing something similar with its lens. It's more electronically, obviously. It's not really done mechanically, but because of that, it can also produce way clearer pictures.
The comparison that we can bring here is, especially for people who are wearing glasses like myself, if you take the glasses off, you can see, but not very well. I would say that it's like basically the Hubble telescope in comparison to when you put your glasses on and then suddenly you have a clearer picture and you might be able to see certain difference that you couldn't see before. I think that this might be a very good
I think
comparison.
even better would be, let's say you have a color perception issue, as we both have,
Yeah.
and now suddenly we can see all colors. The world would look different to us suddenly because we are not used to it. So we can suddenly see way more information. There's actually there's also one thing called quadrotetrachometry. I think that's how you pronounce it. It's when it's only found in females where they have an extra receptor for a yellow band. And they can suddenly see, like these individuals, it's a very rare condition, they can see more colors in yellow, similar to what bees do actually. So for us, they could paint a picture on the wall. For us, it would just be plain yellow, not even with shades or anything. But these individuals, they can see whole paintings in there with like a whole spectrum of colors, millions of colors extra. So that's a better difference, I think, to make. We can't really even imagine how different that would be. You can't, the Hubble telescope, you can't just put another lens in front of it to make it better. Wouldn't work. It's a complete different eye.
It's a completely different technology. Yeah, I
Yeah.
agree.
Yeah.
It's similar to when we compare the human eye to the eye of a fly, for example, right?
Yeah.
It is like the eye of a fly is like actually many eyes in comparison to what we have, which is like two in most cases, right?
Well, one eye per eye.
One pie. Yeah, exactly. Yeah.
Aye, Captain.
I Captain. All right. let's keep it light for today. I hope you enjoyed our show, and if you did, please like and subscribe.
And don't forget to hit that notification bell. And we also have other episodes. Sorry, you can say that if you want.
No, I wanted to say the comment, but you go ahead.
Yeah, okay. So what I wanted to say was we have more episode than this one, and we would love your comments on all these older and also the new episode, just to give us some comments and some feedback, and we might consider your suggestions for future episodes.
Yeah, we already work on one from one of our fans.
Yes.
Coming up soon. All right. Have a good one. Bye-bye.
Bye.